This week on Quality Digest Live, what's the difference between political discourse and quality discourse?
Plus, I went further with Ford. What do I mean? What do I mean? Good question.
Good question.
We'll find out when we come back.
This week's sponsor of Quality Digest Live is Olympus NDT. The new OmniScan flaw detector is the latest product of Olympus NDT's dedication to developing hardware and software advances.
Welcome back to Quality Digest Live for June 28th, 2013. QDL is your weekly look at who and what is making the news in the world of quality. I'm Mike Richmond, Quality Digest publisher.
I was just trying to throw you off on that.
I know you were. It's fine. I saw it. You know, it's all good.
And I'm Dirk Ducharme, Editor-in-Chief of Quality Digest. Well, researchers working to design new materials that are durable, lightweight, and environmentally sustainable are increasingly looking to natural composites, such as bone, for their inspiration. The reason they're looking at bone is really tough. And it's tough because of the complex of arrangements of two of its materials. You've got soft collagen protein and stiff hydroxyapatite mineral. And these, the patterns that these two minerals are arranged will change depending upon the scale of the composite, in the case of bone, from really small bones to really large bones. So if you think about it, collagen by itself in bone is really too soft and stretchy to serve as a structural material. And hydroxyapatite mineral is brittle and prone to fracturing. But together, they form this remarkable composite bone that is capable of supporting the human body. And if you think about it, it's pretty amazing. You've got this, basically the skeletal structure of anybody is about the same for the same size person. And so you have these, let's say a big bodybuilder, right? Their skeleton is the same size as you or me, right? And yet you see them hoist, you know, what are these guys who press, what are they pressing, 800 pounds or 1,000? Yeah, exactly, right? And yet the skeleton is supporting it. So scientists are really interested in what they can do using that as kind of a basis. So that was the goal for researchers. Can you 3D print something like bone with its remarkable qualities? Well, in a paper published online in Advanced Functional Materials, Associate Professor Marcus Buehler of the Department of Civil and Environmental Engineering at MIT and his co-authors describe an approach using computer-optimized designs of soft and stiff polymers placed in geometric patterns that replicate nature's patterns and a 3D printer that prints with two polymers at once. The team has produced samples of synthetic materials that have fracture behavior similar to bone.
Wow.
Now, one of the materials in this is 22 times more fracture resistant than its strongest constituent material. Did I say that right? The composite, yes. So the composite itself is stronger, 22 times stronger than any of its constituent materials, just like bone. So collagen by itself isn't any good. The brittle stuff isn't any good. Together they're really strong. And they've come up with a material that does that. So according to Buehler, the process could be scaled up to provide a cost-effective means of manufacturing materials that consist of two or more materials, tailored for specific functions in different parts of the structure. So as an example, he says eventually you might see entire buildings 3D printed with optimized materials, electrical circuits, plumbing, energy harvesting, the works, all 3D printed, but with different functions being carried out depending on the structure of the composite that they put together.
Yeah. And it's the same principle. And the edifice of the skeleton of the thing will using this composite will be stronger, just like they found this out with bone. They can 3D print these materials, and together they're 22 times stronger.
And by the way, the secret to this is that there are already 3D printers that print with multiple materials. As a matter of fact, very often, a lot of them, they'll print, let's say, ABS plastic and another type of material, sometimes as a filler material. So the printers are already out there. It's really, what are they going to print with? What two materials are they going to print with? The squishy material and the brittle material, and what is the structure that they're going to print? And that's what the secret is behind these super strong composites that are capable of being 3D printed. It's amazing stuff happening in this field. It's growing exponentially.
Every week, it seems like we're coming out with another story that we're covering on the show that really is amazingly taking it even further than we ever would have thought. I mean, would we have thought about this 10 years ago? I mean,
not even 2 or 3 years ago.
When I first heard of additive manufacturing, I was like, huh? Why would you even want to do that? I mean, pretty crazy, pretty amazing. All right, well, also in the news this week, Michael Causey is taking on the FDA again. Is that news?
No, he takes on the FDA pretty much every week.
I guess that's news. Well, Causey's piece, which ran in Quality Digest Daily on Wednesday, is titled FDA to Plug Holes in Medical Device Security Systems. So according to research conducted and gathered by Causey, online security for many medical device manufacturers is depressingly, and one might almost say shockingly, lax. Earlier this month, in fact, the FDA issued a new safety communication advising hospitals to take these threats more seriously, and it is a big threat. You know, the issue here is that because of the weak security, and what they're talking about with weak security is the same weak security any of us have with anything that's online.
They're computers.
Computers, but we're talking about poor passwords, really.
Right.
I mean, so the thing here is that it's easy to figure out passwords for medical devices such as surgical equipment and patient monitors. Patient monitors, right? I mean, this is a big issue. This is an important thing that could affect health and safety for a lot of people because basically people are really lazy with their security protocols. I mean, they use passwords that you can figure out in a minute. Not that hard. But there are common sense solutions to this, and they include limiting or eliminating unauthorized access to devices, employing so-called fail-safe modes to ensure that devices' critical functionality is maintained even in the face of a security breach, and beefing up retention and recovery methods. All those things are intended to make it so that if there is a breach or there's a problem, what people need to live maybe or to be healthy and to be safe will not go down. They won't, again, these fail-safe modes will continue to run. That's very important. I mentioned, of course, these are important issues that Causey tracks on a regular basis. Again, as I said, this is what you're going to hear from Michael when he appears in the pages of Quality Digest Daily. He's going to talk about these issues with the FDA. Not particularly this issue all the time, but issues with the FDA. So we're tracking him regularly, we're bringing him regularly, and we're going to continue to do that. So you can check him out, you can check out this article, along with all the pieces that Dirk and I are going to be covering on today's show, right beneath the video player screen, right down there.
That's right.
Yep.
Well, if you've been working in this business long enough, you know that when it comes to hyperbole, generalizations, and deliberate misunderstandings, politicians hold a dim candle to quality experts.
Yes, I think that's probably true.
Well, and to illustrate this, we're going to use an article, a good article. This is an article by Mark Graban. He writes a great blog, and he works in the healthcare industry. And this article is actually a good example of kind of what happens when you get a lot of different quality experts talking on a topic that they're very passionate about. Mm-hmm. So we'll just kind of set this one up a little bit here. In Graban's article, you can't always believe somebody saying Toyota would tell you to. That's the name of the article. Mm-hmm. Mark tells the story of a recent lecture on lean that he went to. At one point, the professor talked about takt time, T-A-K-T, mm-hmm. I'm not sure how to pronounce that, or the rate of customer demand, and how we balance the service or production time to match up with takt. In his hypothetical healthcare example, the professor said, let's assume that a doctor's office is supposed to be seeing a patient every 20 minutes. Well, what if the patient has been in the room for 19 minutes and 59 seconds already? Well, according to Mark, the professor said Toyota would tell you to kick the patient out of the room at 19:59 because you have to keep on takt time. So, of course, Mark disagreed with that, arguing that at Toyota you would not kick a car off the production line because some sort of problem was holding it up. You would stop the line, and then he went on to discuss this a bit, how Toyota deals with issues and how that applies to healthcare and so forth. So, there's a couple different things I want to bring out here. Mark did something that I think a lot of us do. The professor, his point wasn't what's going on at Toyota, right? His point was, look, we're going to talk about healthcare, how things work in healthcare. We're going to talk about takt time. I'm assuming went on to say, how do you improve your system and so forth. Yeah. And it was kind of a line he threw out. If you were at Toyota, they would just tell you to throw the patient out.
Yeah.
Now, obviously, that's not true. And Mark was probably right in this particular instance in saying, wait a minute, you've got that kind of wrong. But the point is, that was kind of an aside by the professor. That wasn't the crux of the professor's story. It was kind of a line he threw out there. But I see this happen a lot. You see it in political arenas. You see it in quality arenas. It's kind of like, no, as a quality professional, that bugs me. You said something about Toyota and it's wrong, even though it really has nothing to do with the overall scope of what the professor's talking about. And so Mark grabbed on that. Now, the funny thing about it is, Mark is a kind of a controversial writer, and anytime Mark writes an article, he'll either have Kyle Topazzini or Trip Babbitt that'll come on and take issue with him. And of course, when those guys write for us, so they're always. The thing is, though, very often, and this is kind of the point of what I wanted to talk about here. Very often, they're not addressing the overall substance of what the author or the lecturer or everybody is saying. They're looking for. It's almost like they're looking for something to disagree with, so they have a launching point to put forth their own particular theory, their own particular view, and it's almost a distraction on some levels. You know what I'm talking about?
Well, it's interesting because the analogy that you built into this story was that of political discourse in this country, or really anywhere in the world now, where politicians do the same thing, and the term you're looking for is reframing. And it's always about who's going to frame the discussion and who's going to control the argument and who's going to pick and choose which part of that they're going to counter. And what it really comes down to, I think, is these aren't discussions. These aren't discussions. If they are discussions, they're one-sided discussions. Somebody is saying something and the other person is listening, kind of, but really what they're doing is they're looking for an entree. And they're looking for an entree
launch from.
To get into what they want to say. So it's like you've ever been at a party and it's like you realize you're talking to somebody and really all they're doing is waiting to talk themselves and they're not listening to what you're saying. They're kind of like, they're like waiting, and then they'll say something that maybe was kind of tangentially related to what you just said, but really they go off in a totally different direction. And it's like, well, didn't you just hear the last 15 minutes or 20 minutes, half an hour, 2 hours of what I just said? But it's similar to that. I think it's similar to that because I think it is not conversation. It's not the art of conversation. It is the art of kind of listening, jumping in, and getting your point across. And that's reframing. And I think it's damaging, personally.
Well, I don't know. Okay, so it's funny. You mentioned that, and that's kind of what I want to talk to. We just got another minute here. On the one hand, it's like, oh, come on, dude. You've totally launched off onto another topic, and you're deliberately misunderstanding.
I think it is deliberate sometimes,
On the other hand, it's what kind of keeps conversations going as well. So on the one hand, it's distracting, and I get distracted by it, but on the other hand, it allows you to bring in sometimes another point of view that is usually tangentially related. So I'm not sure where the balance. I'd hate to see it go away completely because it's kind of what gets things rolling and gets all these different viewpoints in, because these guys are all passionate about quality. And you listen to Tripp and you listen to Mark and you listen to Kyle and you listen to Don Wheeler and Balistracci and all these guys. They all got really interesting things to say. So I like when they jump in, even if their premise for jumping in is somewhat loose.
Well, and the other thing is, I mean, we are talking about quality assurance. We are talking about the act and the profession of improvement, and that requires a very tight focus on the detail. So, further to the point, to your support for this, is like, well, are they taking it off in a direction, or are they kind of setting up a straw man argument and picking out one little piece of that? Yeah, but maybe they should. Maybe that's okay to do that too, given what we're all trying to do here, which is to ensure excellence.
And I'm kidding. Moving on, hair to my ear. One thing, I do think it is critical, though, that you do, like correcting the professor. Maybe it is important. I mean, I think this is what they would argue, is these guys would all argue, look, even if it's just hyperbole, even if it's just a throwaway line, as quality professionals, our job is to be precise. I mean, the quality of our product and service depend on it, and you can't even, they might argue, and Graven might argue, look, you just can't have a throwaway line like Toyota would do this if it's wrong. It's like, no, I mean, these are systems that are in place and they're tried and true, and you can't be besmirching them in a way. It's like these are important things, and don't get it wrong. And I think that's kind of the argument they would use, and I'll end with that.
I think so. Good. Well, if you have more further thoughts about this, write us at qdl@qualitydigest.com, and let us know what you think. If we can't get it on the show today, we'll respond to you. Maybe it'll be the basis of a further article we'll do on the show at some point in the coming weeks or months. Right. Okay. Well, from Toyota to Ford, I and Ryan Day, my colleague here at colleague here at Quality Digest, attended the Go Further with Ford event, Trend Conference in Dearborn in Detroit, Michigan, earlier this week. And I wrote a story about it. I wrote a field report story, and the title is, we call these field reports when we're on the road. Field report, Go Further with Ford, and that appeared, for me, it appeared in yesterday's issue of Quality Digest Daily. I want to preface this, Dirk, with a little story about travel. Travel in the 21st century in America is a beautiful thing. We have 3 canceled flights. This was very similar to a planes, trains, and automobiles experience. Ryan and I did not end up in bed together. There were no hands between pillows or anything. Not a pillow. But it was interesting. We had a couple of canceled flights going out. We ended up flying in and out of, I think, 3 different airports in California, or we tried to. We had to reroute ourselves back. My wife had to pick us up in San Francisco and drive us to Sacramento, and then we drove back up to Chico. A lot of late nights. There was some driving involved because we missed our connection, or they canceled our connection from Chicago to Detroit. So we drove from Chicago to Detroit to make the show in time to be there on Tuesday. And we had a great, productive, wide-awake day after an hour of sleep. But it was great. And Ford was wonderful hosts. And the reason why Ford was really a great host and why this was really interesting and really was valuable was, we've all heard about trend conferences. We've all been to trend conferences. They're all kind of all the rage these days, especially in Silicon Valley and other high-tech centers, where people will gather together their users and some media types like Ryan and myself, and they'll talk about what they foresee coming up. And there's a lot of kind of platitudes. There's a lot of, well, here's where we've been, and kind of self-congratulatory, here's where we're going. And there was some of that at Ford. But really, what Ford did here, which was cool, is they did a lot more than that, and they allowed you to really kind of roll up your sleeves and experience what they're doing and what they're seeing and what they're going to be doing going forward. One thing they did, which was really interesting, was they allowed us to get behind the wheel of an F-150, in Ryan's case, an F-150, and drive around Detroit. And it was part of a program they do where their employees would kind of donate their time, and you can see kind of some of the prep time for that, some of the prep work in the photo there where we were going out and Ryan was going out and doing some driving. There's one of the F-150s he drove. And you drive around Detroit and you do good work. So it's about the greening of the city. Sure. But it gave us a chance to drive the car, drive the F-150 a little bit, have an understanding for some of the powertrain and the way the car handles, as well as some of their touch probe stuff. And I'm going to get to the My Ford Touch in a minute, because that was something that's interesting and controversial a little bit about some of their haptic technologies. The other thing they had, which was unique, was truly powerhouse speakers. I mean, this was only a group of about 400 of us, but the lineup of speakers was incredible, really amazing. I mean, not only Bill Ford and Al Mullally, the top management of Ford, but Steve Wozniak was there and spoke, which was great. You saw a picture of him earlier. Sherry Turkle, who's an amazing speaker. Seth Godin, another amazing speaker and writer. Many, many others, and really having a sense for what the trends are. And as Bill Ford said, Ford's not an automotive company, really. They're what they call a mobility company. They're a communications company. So they're moving into these realms, and a lot of this was about figuring out what that all means in terms of using your car as a central point of your existence, your communication with the world, and how that's going to roll forward. Let's get back to the My Ford Touch for a minute. This was obviously a controversial thing here in the last year or so, where Ford really had some issues with that. And the Ford speakers did not have a problem shying away from it. They said very clearly, hey, we have problems. We stubbed our toes on it. But what it was about was innovation and going where we know we're going to need to go. And that haptic technology is going to be involved in automotive. And Ford is really leading the way on that to a large extent. Now, Ford, quite frankly, suffered a little bit for that in the latest J.D. Power and Associates initial quality survey, where Ford was relatively low, pretty darn low in that survey, given initial quality. But a lot of that, the vast majority of that stems from the My Ford Touch, which was a problem, and that caused a lot of the problems. Not so many problems with a lot of the other stuff, but problems with that particular system. And customers are happy. Customers are generally really happy with Ford.
And
the quality is good.
they sent out an upgrade for that, right? And
they did.
basically remedied the issues, right?
It remedied many or most of the issues, but still there were initial quality. The report that came out in JD Power was certainly part of that as well. So there's problems. There's problems, but there's also a lot of innovation. We saw a lot of really cool stuff there over the past couple of days. We hoisted some of their lightweight materials that they're using to build their cars. Amazing. I mean, amazing when you lift something that was in a car 5 years ago versus the material that they're using now. It's a third of the weight. It's amazing. We saw the way they're using some interesting test and measurement technologies. They're doing some interesting things, and you saw it earlier in the photos, with thermal imaging and testing with thermal imaging airflow and air escape, so the hissing that you may have through a car door, maybe, for instance. Okay. You can find where there may be holes. So a lot of good stuff, a lot of interesting activity for their venerable, obviously 110-year-old company. We had a really good time there. We're going to be working a lot with Ford going forward, Ryan and I. You're going to see a lot more from us. Ryan's got a piece he's going to file here very soon with some more photos and some video as well that we took while we were there. And later on this year, we'll be doing more with Ford. Obviously a good quality-oriented company in the manufacturing space, and we're looking forward to bringing in more information about that coming soon.
And hopefully we'll be going out there again next year.
We will. Yep. Hopefully going to go further again, even further, and hopefully we won't have to travel like we did last time. Okay. Now, we're going to turn now to our tech corner for this week, and this is a good one. As we always like to do, we have a guest in the studio. Rob Bellinger of Olympus America is with us. And Dirk and Rob are going to be looking at the Olympus's OLS 4100 LEXT equipment. And take it away, guys.
Oh, yeah. Well, Mike said, I'm here with Rob Bellinger from Olympus, and this is the OLS 4100, and this is a microscope, is that right?
Yes, it's a laser scanning confocal microscope, to be exact. It's a precision measuring tool capable of very high resolutions and high magnifications as well. It's statured in the R&D and quality control type areas for its use. Some of those markets range from semiconductor to aerospace to medical device, even down to forensics and larger type material samples. So it has a broad range of mags for larger samples, all the way down to your very small semiconductor type samples.
You said this is both laser and optical?
Correct. So it utilizes a laser for the higher resolution imaging and to place all the Z points to create three-dimensional images. It's a confocal tool, so that means it takes very small slices of focus and renders them into an all-in-focus three-dimensional image. When it does that, it captures all the height data as well. It does also incorporate white light color imaging that can be overlaid on top of the standard image to give you some more depth perception to the image to see if the defect was a certain color type or something of interest that you were looking for.
And I believe you said this is really high, or capable of really high magnification, so that's
correct.
Optical magnification, I'm assuming.
Optical magnification down to almost 50x, all the way to over 17,000 times magnification.
And that's optical, not digital.
Optical magnification. Okay. And it's also capable of very high resolution, so 10 nanometers in Z to measure very small surface structures or surface roughness. And it's capable of doing three-dimensional imaging, so we can measure steps, we can measure volumes, and all of that different stuff. The new user interface with the 4100 makes use as simple as possible. So most people that have ever ran any kind of microscope can walk right up to the tool, quickly move around their sample with the live color imaging mode, of course, and then it's just a simple button push of acquisition. With the new software on the 4100, we're capable of doing ultra-fast scans. So single button click generates a smart scan feature. So this is going to have the tool setting all the parameters for you. Brightness, the set points for heights and your focus.
This is kind of like a quick pre-scan just to kind of see where...
Correct. A real quick pre-scan, see the brightness levels, see the points of focus to where it needs to scan through to take the actual image. As soon as that completes, it'll go through and take its normal scan, capture all the high resolution image, and then it'll capture a color scan as well, since we selected to capture color on this.
Okay.
So that was the laser scan. It's very quick, and then it goes through and captures a color.
Is it scanning the area that you're visually seeing, or?
The area that you're visually seeing, the tool also has the capability to do stitching. So you can set a large region of interest, and it'll go through and scan the entire three-dimensional region of interest for stitching.
And stitch it together.
Yes,
okay.
correct.
Right.
So now that it's done, you'll see that it presents a complete in-focused image for you. We can go to the workflow across the top. We set the measurements, and we're capable of displaying all the different imaging techniques that it captured. We have bright field color imaging. We have the bright field laser imaging. We could have also selected to do DIC imaging, which is differential interference contrast, that brings out more features on the surface. We can also render in 3D. And
so when you were just doing the scan just now,
correct.
That was actually a 3D scan.
That was a 3D scan, that quick. It
Wow,
went from bottom to top of focus
Okay.
and captured all the data for us. So not only did it capture the three-dimensional data in height, it captured the true laser image, and it also captured the true color image that we can overlay on top. This is our 3D image. We can zoom in and rotate around. And if you see this red line here, this is our line profile. So down at the bottom here, we have our line profile for height data.
Okay.
So this brings in the measurement side of the tool. It can do profile measurements for height and step and cross-sectional area. It can do line roughness measurements, where we can measure some of this tiny little peak roughness on the surface and get your quick roughness measurement. This tool even has an interface to do large area line roughness scans as well. Surface roughness, so if you want to select an entire area on the surface and get the roughness information. And we take all kinds of geometric measurements, like circle to circle measurements or out of field of points measurements.
You can do volumetric measurements as well?
All kinds of volume measurements for depth, like this scrub mark. If you wanted to know the volume that was removed from it, you can measure what's left and what was removed and get the difference between. We have particle analysis measurement, and the tool is also capable of doing film thickness measurements for transparent optical films.
I was going to say, so yeah, for transparent films, you could determine
the
where the
thickness.
top of the film is. And
yep, and the tool with the new multi-layer function will actually scan through and display both layers independent of each other, the optical layer and the solid layer that's below it, maybe a metal surface or something. And if you know the refractive value, you put that in, it tells you the thickness without having to cut it in half.
How's it determining that? Okay, I gotcha. All right.
So it can determine the thickness, just like you would see this graph here, you'd see the thickness between two layers. And all of this information, once you capture it, it's single button clicks, capture your measurement value, and then you move on to your reporting at the top here. Another single button click takes all this information, drops it into a predefined report template for you, so you can export these report templates to PDF real quick.
And what kind of accuracy do we have?
So this system has, like I said, 10 nanometers in Z for Z height and depth measurements, and 120 nanometers lateral resolution measurement. It's capable of very high magnifications, and there's 3 lens choices that Olympus actually guarantees the repeatability and accuracy specs on.
What do you mean by guarantees?
So it's very important that a measurement tool that's in especially an R&D fab, that it's guaranteed its measurement accuracy. You don't want to take your measurements and not know if they're right on or if they're a few percentages off. So when the system's set up, the engineers perform test scans on traceable standards, and those guarantees are brought forth on all 3 of the high-powered lenses on here. Since we're an optics company, we manufacture the lenses specifically for this laser tool, and we can guarantee the results from those. So the 20, the 50, and 100x objective are all corrected.
Okay.
And that allows us to spec, guarantee accuracy and repeatability.
And I think you said the market for this really is more R&D. Is that the
R&D, quality control? It's falling into place for inspection on circuitry, backside inspections. You have everything from like forensics, looking at the striations or tool markings, so larger samples can fit under here as well. Medical device, a lot of their circuitry and boards are looking at finite wiring and stuff like that.
Okay. Actually, Christopher, is that a question related to the Olympus here? Okay.
So.
Okay, we have a question. What is the difference between optical and digital magnification?
Sure, great question. So this system is capable of having an optical image just like your normal microscope. So it's limited to the objective. The objective magnifies the light to a certain value. Right now we're magnified about a little over 1,000 times magnification here.
So that's straight optical. That's
straight
just
optical
coming through the lens.
Through the lens,
right.
And normal microscopes are limited by that. When we switch to the laser, it's actually scanning the image now, and the laser can increase its magnification by reducing the scan area without any resolution loss. So this is complete optical magnification. So if I zoom in now, higher and higher the magnification goes, I'm over almost 3,500 times magnification here with the same exact lens, just a smaller reduced scan area. same resolution capabilities, higher magnification. Similar way that scanning electron microscopes get their magnification as well.
Okay. And I think sometimes, maybe to address more what the question was about too, sometimes there's this thing called digital magnification where you simply stretch it, but you're not necessarily seeing any more detail, you're just seeing
so if I take
a little closer up, right?
If I take a look at our color image here, we can't stretch white light, we can't make it scan or anything like that, but we can digitally zoom it. So that's what we'll do here in color, is we can digitally zoom, and now you see the resolution drops off.
Right.
The reason it drops off is the pixels only can cover so much. So you're digitally zooming and you start pixelating your image.
Yeah.
Compare that to the laser, which is going to have incredible resolution.
Right.
So,
and you're saying this is only 3,500 right now or so?
This is about 3,500 times magnification.
And you can go up to 17,000.
With the higher mag lens, the 100x, we can go to 17,280 to be
So
exact.
the laser is actually using the same lens as the optical, is that?
Exactly. Yep.
Okay.
It's the white light and the laser light run through the same lens.
Okay.
It's just the laser has the ability to scan smaller areas and increase magnification.
Okay.
Very high.
So is this? You mentioned the interface is looks pretty straightforward. Is this a product that is pretty simple for somebody
Correct.
who was obviously familiar with microscopes and so forth? Pretty straightforward for them to get up and learning pretty quick.
Yeah, it's really interesting. The interface is so simple that one time we were set the system up, we hadn't even gotten done setting it up entirely. I hadn't even turned it on, and some user that was in the lab just walked up, sat down, and started getting images. And I walked over and said, well, we weren't even ready yet, but they had picture, 3D image, all done.
Yeah.
They'd never seen the tool before in their life. It really is as simple as one button clicks for acquisition. There's even wizard functions built into the tool that can guide someone through every single step, setting the sample on the stage, creating the focus, getting perfect focus, setting their magnification. It walks them through every step. So it can be a very multi-use kind of lab where you don't have a high training time put into the tool.
And you said there's a certain amount of automation in here. It isn't a fully automated product necessarily, but
not fully automated for auto detect and find and measure, but it does have the capability of doing auto stitching for large area
or programming,
imaging, and
programming certain areas for go here and measure this, or go here and scan this.
Exactly. Yeah, we call it advanced acquisition, and we can put an origin point and deskew our sample and drive back to a predefined list of 100 points and have it three-dimensionally scan every one of those points. And then after that's done, it can walk through the wizard function of measurements. So it can guide the user to take certain step measurements or volume measurements on all those 100 points.
Okay.
Yeah.
And is this part of a series of products, or is this it?
This is in our metrology group. This is our high-resolution model for our metrology system. We also have a what we call a toolmakers type microscope, a measuring microscope that's much more manual and low mag. This is kind of a standalone system for its resolution and capability for surface roughness.
And I didn't mean to ask, volume, measuring volume?
Yes, we did.
I don't mean to measure volume. I mean size of the stage and
oh yeah, sure. So this system is our 4-inch stage. It's capable of 100 millimeter tall samples, so you can fit like a Coke can under here if you want to. We also have a 12-inch larger stage version that has the capabilities fitting 12-inch wafers or larger samples.
So
as well.
Same optics, just different
same
stage.
Exact optics, bigger stage.
Bigger stage.
Yeah.
Okay. All right, that's it. Okay,
Yeah.
Rob Bellinger from Olympus and the OLS 4100. Rob, thanks you for
thank you again for letting
us
us come in.
Sure.
Appreciate it.
Back to you, Mike.
All right, well, there it is. Thank you, Rob, for coming down and showing us the OLS 4100 LEXT Olympus America digital microscope. It was nice to have Rob with us in the studio. Rob's come down now 2 or 3 times to demo different products with us. I think this is his 3rd time down, and always does a great job. So thanks, Rob, for doing that. And I also want to offer one more thanks to the sister company, Olympus NDT, today's sponsor of Quality Digest Live. With the introduction of the OmniScan SX, Olympus NDT continues to expand the coverage of the OmniScan family, making phased array technology more accessible and affordable. For more information, visit online at www.olympus-ims.com or just look at the banner ad right below, or I guess just to the left, right out of the player page right down there.
There you are.
Yeah, that's it. Great.
Okay, well, that wraps up our show for today. Thank you all for joining us. We won't be here next week, right?
Next Friday is the day after the 4th of July, so we're going to give you all a day off. Enjoy that. Take your time and celebrate. Have an extra barbecue on us. And we'll be back at you with Quality Digest Live on the 12th We'll be back on Monday, the 1st, this week coming up with another, almost a full week of great content on QDD.
There you go.
So it should be a fun week. And so have a great weekend, everybody. Enjoy your 4th.
Happy 4th.
And we'll see you next week.
So long.
Bye.
Optical.